Hey guys, welcome back for dimensional analysis example 2. Okay, so at first glance you're probably thinking, whoa, that's a huge question, and don't worry, it's pretty long, but we'll get through it. Okay, so here it is. 3 students derive the following equations in which x refers to distance traveled, v the speed, a the acceleration, okay, they give you the units here because it hasn't yet been defined, meters per second squared, and t the time, and the subscript, you see, it's a little zero here, means a quantity at time t equals 0. Okay, usually the subscript is meant to represent initial, and it's actually given the name not. Okay, so for part A, x equals vt squared plus 2at, b, x equals v naught t plus 1/2 at squared, c, x equals v naught t plus 2at squared, and the question is, which of these could possibly be correct according to a dimensional analysis check? Okay, so we have to check these one by one. There could be one or more accurate answers. Okay, so let's go ahead and do that. So I'm going to go ahead and put part A on a new sheet of paper. Okay, vt squared plus 2at. Okay, so let's go ahead and solve this, shall we? So just like before, dimensional analysis is done using square brackets. So that's the first thing I'm going to do. Replace everything with square brackets. Okay, you've got our v, the t is getting squared, plus, now remember, if you remember in the previous video I said numbers or coefficients, they don't change the unit, it just changes the size, which is why this dimensional analysis can be used to determine if the equation is incorrect. But unfortunately, it can't be used to determine if an equation you make is correct, okay? Because you might be missing like a 2 in front or a 7, who knows, okay? But there might be a factor missing. Okay, so I'm just going to put that 2 there, a t. Okay, now if you remember, the question actually gave us some units. Okay, we know that the unit for distance x is meters. Okay, time is seconds. Okay, but there you have that raised to the power of 2. Okay, acceleration, they tell us, is meters per second squared, and time again is seconds. Okay, so v is meters per second. Forgot to fill that one in there. So they give us everything. All that we have to do is figure out, well, does it match up? Does the right side equal the left? Okay, so I'm going to go ahead and put an equal sign there. Okay, question mark. So we've got 2 s's here. Okay, one of those s's is going to cancel out with this s here. On the right part, you've got one s here canceling out with one s here, leaving you with the unit of meters per second in this term and the unit of meters times second in this term. Okay, so that does not match up, and they definitely don't match up with what you have on the left. Okay, again, remember, this is irrelevant because it doesn't change the unit. Okay. Okay, so we can still figure out if the equation's right or wrong, which in this case, it looks like it is not equal. Okay, so A is not equal. Let's move on to part B. Sorry about that, guys. I got a little bit of a cold going here, but still staying strong. Okay. X equals v naught t plus 1/2 at squared. So just like before, you're going to replace the quantities with square brackets for x. V naught t plus 1/2 a t squared. Make sure you write that squared on the outside of the brackets. Okay, so x has units of meters, v naught has units m over s, t has units of s, a m over s squared, and again t s, but watch, it's getting squared here. Okay, so for this example, we can cancel out the second squared here with the second squared here, and we can cancel out the second here with the second here, because there's one of each. Okay, so we're left with units of meters here, and we're left with units of meters here. Okay, so this looks pretty good. Now, you have to be careful, because if you remember in the previous question, well, in the original question, I should say, it says, which of these could possibly be correct? Okay, so they didn't add extra words there accidentally. It's there on purpose. The reason it says could possibly is because, like I mentioned before, we don't know exactly what this coefficient might be. Okay, so therefore we don't want to say that this equation is correct. We say, therefore, this equation could be accurate, right? Because even if that number was a 6 million, this unit analysis or this dimensional analysis would still hold true. But that would give you a much different number than having a 1/2 in the front. Okay, so we're not quite done yet. We still have to do part C. So let's go ahead and do that. Okay, so C, we had x equals v naught t plus 2at squared. Okay, so let's go ahead and do this. Replace your variables with square brackets. Okay, again, we don't know exactly if this is going to be accurate. V naught replace with square brackets, t brackets plus 2a t, and you put that square outside of the brackets. Okay, so the units for x, again, are meters. Units for v naught, again, it doesn't matter that it's initial velocity or initial speed. It's still a speed, so it has units of meters per second. Time has units of seconds. You get the 2 in front, acceleration, meters per second squared. Time, units of seconds, but it's getting squared there. Okay, so let's see what we've got. Your s squared here cancels out with the entire s squared in the denominator here. Your seconds in that term cancels out with the seconds in that term, giving you the units of meters, and here the unit of meters. Okay, so our units match up once again, but if you remember what I said in the previous part, in part B, see, if you actually notice, this is the same question. They just changed the coefficient. Instead of a 1/2, here it's 2. Okay, and obviously they can't both be correct, right? You can't find the distance by here multiplying by 2 and by multiplying by a 1/2, right? It's not a pick your own coefficient problem. So we have to say, therefore, this equation could be accurate. Okay, so overall, I mean, B and C could be accurate. A definitely is not because the units don't even match up. Okay, we don't yet know what the correct coefficient is, but that's okay because the question's just asking us which could possibly be correct. Okay, so that sums it up for dimensional analysis example number 2. If you enjoyed this video, guys, be sure to give that like button a click, subscribe to my channel so you don't miss another video, and that's all for today. Thanks, guys.